look at industrial knowledge. Your brain will become irreversibly intelligent. The next thing I would do is, in 36,500 days, bring you to understand the core principles and practical knowledge of all industrial automation. Today, we will talk about laser cutting machines, but before we talk about that, I would like to ask you a question first. Can laser cutting machines and traditional plasma cutting be used interchangeably? Laser cutting is so expensive. Is it really worth it? Trying to figure this out. We need to figure out two things. First, what is the difference between these two cutting methods? And what materials and occasions they are suitable for? So, here's the simple answer. Plasma cutting relies on a high temperature arc to heat the gas to tens of thousands of degrees. They form a plasma. We use this hot gas to melt and cut off the metal. Low cost, thick cut plates. A device can be used for tens of thousands of dollars. There is no pressure when cutting 100mm thick steel plates. Laser cutting relies on high energy beams of light. The laser is focused to a tiny point, extremely dense energy. The metal vaporizes directly. The cut is only about 0.1mm. The cut edge is smooth and flat. Basically, no subsequent polishing is required. Therefore, from the perspective of cutting accuracy and incision quality, lasers are indeed a bit stronger. But here's the thing. Being strong is one thing. Whether your site is useful or not is another matter. Materials have a key parameter, thickness and accuracy requirements. It's about 25mm thick. Sheets with high precision requirements. Laser cutting is the most suitable. For example, automotive body parts, electrical enclosures, and precision sheet metal parts. The laser goes down. Accurate size. The edges are polished. Go straight to the next process. No need to polish. Medium thickness plates between 25 and 50mm thick. Both lasers and plasma can do it. Look at the accuracy requirements. Choose a thick plate with a thickness of more than 50mm. The speed of laser cutting has dropped significantly. Costs have skyrocketed. At this time, plasma or flame cutting is more costly, such as shipbuilding, heavy machinery, bridges, steel structures. Dozens of millimeters thick steel plate cut with plasma is fast and saves money. If your site was supposed to use plasma, you switch to a laser. The accuracy is even higher. But laser cutting thick plates, it's slow. It consumes a lot of power. The equipment itself is hundreds of thousands, tens of millions. And the same life, the cost is several times more expensive. Totally unnecessary. On the other hand, if you have to use lasers on site, you used plasma. That would be troublesome. Plasma cutting has a fatal flaw. That is, the slit width and heat affected zone are large. There is an oxide layer on the edge after cutting. Dimensional deviations can be a millimeter or more. It also requires a lot of hand sanding to work. Precision parts are cut out with plasma. When assembling, I found that the size did not match. A batch of parts were all scrapped, but you have absolutely no idea. The problem lies in the cutting process, and many people don't know. The laser cutter also has a hidden pit. It's the wrong cut. Gas. Laser cutting requires three options of auxiliary: gas, nitrogen, oxygen, and air. Cut stainless steel with nitrogen. There is no oxidation in the section. Silver, white, light. Cut carbon steel with oxygen. Oxidation, faster combustion, but the cut surface has an oxidized color. If you use the wrong gas, stainless steel is cut with oxygen. The cut surface is black and oxidized. The whole batch of parts is scrapped. The customer returns the goods directly. A novice would step on this pit almost once. However, there was one exception. There is a material, the laser cutter hits it. Direct reflection of laser light. Can't cut in. It can even damage the cutting head. But the engineers used a special scheme, cut it into precision parts with an error of 0.05mm. You know what this material is?